Hi friends, welcome to Raspberry Pi IoT series. So from this session we can start doing some simple examples with the Raspberry Pi. Our first program is to just turn on an LED. With this program you will get an idea about controlling the GPI ports of the Raspberry Pi. So in this example, as you can see, one LED is connected to one of the pins of the Raspberry Pi. The pin to which the LED's anode is connected is GPIO.17, that is the general purpose input-output pin number 17. The physical pin number is pin 11. You will get a clear idea about that from the pin layout of the Raspberry Pi. This is the pin layout of your Raspberry Pi. Actually, in the 40 pin layout boards, the total number of pins are arranged in 2 rows. The physical pin numbers are like this: 1, 2, 3, 4, 5, 6, like up to 39, 40. The GPIO pins numbering systems are not continuous, so you have to find out from this map, or you can also use the pin out command that we have discussed earlier for finding out the pin layout. Anyway, in this example we have shown that the LED's anode is connected to a GPIO 17th pin. So the GPIO 17th pin is, as you can see in this layout, it is the physical pin number 11, that is the GPIO 17. And if we count the pins from the left side, it will be 1, 2, 3, 4, 5, 6, 6th pin from the left side top. That is the GPIO 17. And you can see a 220 ohms resistor is also connected in between the LED's anode and this GPIO 17 pin. This is just to limit the current flow to the LED. You can use any low value resistor. This 220 ohms value is not specific. And the cathode of the LED is connected to the ground pin. There are multiple ground pins available on the Raspberry Pi pins GPIO layout. You can use any ground. In the circuit I have used the right side, the physical pin number 3, this ground pin I have used. You can use any ground pins. Lot of ground pins are available. So this is the circuit, and we can see how we can wire this circuit in the physical board. So this is the Raspberry Pi board. You can see from this video. Now we can connect this LED to this Raspberry Pi board. As you can see, we have already discussed that GPIO 17 is 6th pin from the left side. 1, 2, 3, 4, 5, 6. So we can count that in the physical board and connect to the LED's anode there. That is pin number 1, 2, 3, 4, 5, 6. This is the GPIO 17. And the ground from the right side is the 3rd physical pin. 1, 2, 3. You are free to use any GPIO pins as per your choice. I just used the GPIO 17 for this example. So we have connected the LED now. Now we can do the programming part. So we have already logged into the Raspberry Pi. We can write the program now. We have already discussed how to write the program by inside the directory of our choice. So I am not going to elaborate those things now. I am just writing the program now. We can give any name for the program. I am just giving the name as LED. So the extension will be LED.py. Now this is the program we need to use in this example. This is the first line, that is the import line. This is used to use the importing the RPi library for using the GPIO pins. And this LED pin, we are assigning a name to the GPIO 17 because we are using the GPIO 17 for connecting to our LED in this example. So we are just giving a name. LED pin, I have given the name as LED pin. You can give any name. And the next GPIO.setmode. GPIO.setmode is used for setting this pin layout as the Broadcom chip specific pin numbering system. So you can just follow like this in this example. Actually we can do in another mode also, that is we can use as the physical numbering system. Don't confuse that with this. In this example we can just follow this GPIO.BCM numbering system. Just to follow this line like shown in this example. The next is the GPIO.setup, that is to determine the pin as an output. We are just setting this LED pin, that is a GPIO's pin number 17 as an output. We are just setting like that. Only then we can turn on the LED that is connected to this specific pin. And the last line GPIO.output is to output, writing output to this specific pin number 17, GPIO 17. So this is the program, and we can now write this to the Raspberry Pi Python file. This is the program. LED pin we have assigned to the GPIO 17, and last we are out. GPIO.out LED pin true means it will output a high voltage to the specific GPIO 17 pin. And we can save this program by pressing Ctrl and O together and then enter, and then for exiting Ctrl and X. So we have written the first program, and we can try executing that now by giving python space led.py, and we can press the enter. Now we can see that the LED has turned on. So our first program is successful. You can try that in your lab, and if you have any doubts you can surely comment below. Finally, to turn off the LED you can again edit the same program and just edit this true to false and save the program and exit and again execute the same program, and you can see that the LED will turn off now. Now we can see another example in next session.